this is a popular syndicated cartoon, and the character, you have this nerdy character, Jason. Has anybody seen that cartoon? Yeah, it's been some time ago. And so what it is he gets a basic geometry problem that if the garden is 20 foot wide by 30 feet long, what is the area in square footage? Well, instead of just multiplying 20 by 30, he makes a calculus problem out of it by putting the equation here, like y equals 20, and evaluating that between 0 and 30, and then he works it all out like this, and so that's it. So he takes a easy area problem and makes it, but it's something that we do too. Like, I'll show you how it works. If you're driving a car at, say, 60 miles per hour. So here's your velocity or speed of driving a car. So here we have 60 miles per hour. And so it goes like this. Your car stays at a constant 60 miles an hour. And you go for 4 hours. How much distance did you cover? How much distance did you cover at 60 miles per hour if you went 4 hours? 240 hours. So this is your velocity. Okay, v of t equals 60. And so it could be like 60 h times the hours, right? So here's h-axis, here's velocity. So here's v of t. Well, yeah, v of t is 60, we'll call it 60t, is what we'll call it. And so graphically, this is what it is. So you're used to see, that makes sense, doesn't it? Okay, and what happens in calculus is you don't need to have this. You could also, what if the thing changes speeds? Is your car really going to change speeds when you do that? Yeah, but then you're still able to use calculus to find that area too. So that's where we're going in the class. Now, what I want to do is I want to show you this. Or I'll ask somebody to tell me what to do here for this one, for number 2.
So are you going to go up 2 over 4?
So up 2 over 4? Yeah, so what we have, so Kinsey is on the trail, okay? So here we have y is equal to 2, and here we go from 0 to 4, do you say that? And so what is that going to be? 8. It's going to be 8, right?
Wow, there's a version time that's...
Yeah, so basically you're doing integral calculus today. And the idea is that we're really going deeply into the integral calculus, more like the second semester. But this symbol is such a weird looking thing. The reason we're starting out the class with this is we want to get you used to something. So when you come back to it, it's not going to shock you, right? You're already comfortable with this.
Oh, first sticker of the year right here. Oh yes. Oh yes, even goes with blue. Feel special. Check.
Okay. Do I have another volunteer for number 3?
I'll try.
What do you think?
I got a question. Can area be negative?
Can area be negative?
Or the last answer can be negative?
I'll just answer you, yes, area can be negative.
Then I went from -2 and then this little dash line.
So like this right here?
Yes. And then I did 1 and drew a line down. And then 5. And so the answer would be -8. So there we go. That'd be -2 times 4.
Yes, that's exactly right. And that's a good intuition, because most students, I've been doing this like for quite a few years now, and most people don't catch that the first time around. How'd you catch that? How'd you catch it? I couldn't even trick you on day one. What gave you the idea to do that?
Well, I was just looking at it, and you have to do the area, so it's 4 on top. It's basically the same as 0 to 4, but it's 1 to 5.
Yeah, okay. And it's below the x-axis. Okay, good. Yeah, that's really good. Let's see, what time we go to? 50? 53? Okay. We may just we may do the calculator portion tomorrow. Okay, here's the next one. Okay, this one is not the same, right? You want me to look at this one?
No.
You know how to do it?
We got it, maybe, I think.
Okay.
What would you do the second one?
You have it, Emma?
I think,
Okay. What do you think?
since it says 1/4, we thought that you go up 1/4 and have one across, and then you have the 4, so you would go up, and then 4 times 1/4 would be 1. So your area would just be 1.
Okay, so 1/4 would be like right here.
Yes, across.
So it goes like this, and then from 0 to 4. So you'd have this area here, right?
Yes.
So you say 1/4 times 4 is equal to 1. Now, graphically, this is not really what it's saying. And so I'm not sure if it's right or wrong. Does anybody else have something else represented here? Is this what you got? Okay, it's a different thing. Because what we're looking for, in this case, we have y is equal to 1/4 x, is what we're looking at. Now, the answer still might be right, but let's take a look at really what's happening here.
I didn't even see the other way.
And so what we're doing here is we have rise over run of 1 over 4, right? So like this, so what we have is this. So here we have y equals 1/4 x, and then we have this area here, and then we have, so what area of thing do we have here? A what? A triangle, right? So let's go ahead and work this out. So we have 1/2, here's our base of 4, and we have 1. So what's our area for this thing? Base times height divided by 2. So area
2.
equals base times height divided by 2. So that's going to be 2. Okay? So the thing changes up, right? So you got to look at the function, what it is. Just like that other one we had where it was, remember it was 8x cubed? Remember that? We had to look at that. Now we're looking at this. Okay? Questions on that one? Okay.
Sam has a question.
Yes? Yeah, let's see here. Hang on. Give me 1 second.
I got a doorstop too.
Okay, number 5. Does anybody have number 5? Elizabeth, what do you have?
So for the y, it's going to be 2 and 4. So 1 and 2, 4 and 2.
So here we have y is equal to x minus 2. So here's the minus 2, slope of 1, so it's going to be like this, right?
Yes.
And we're going from 2 to 4, so here's 2 to 4.
And then when you take the area of the triangle, it's going to be 1/2 of the base times the height. The base of the height is 4, and 4 equals 2.
2, right? Does that look right?
Yeah.
One thing that really helps in doing this evaluation, do you remember last year we talked about even and odd functions? Actually, we did that in Algebra 2 also. Remember even and odd functions? That's going to help you out a lot on these. And we'll review what those are.
I wasn't done.
Okay, does anybody have 6? Kaylee, what do you got for 6?
Starting at 2.
Starting at 2, okay.
Going
Down 1
down
over 2, right? So here's down 1 over 2, so it's going to be like this, isn't it? And we're going from 0 to 4, right? So what do we got for that?
I don't really know what to do about that.
4 times 2 divided by 2.
4 times 2 divided by 2, does that look right? 4 times 2 divided by 2,
That'd be 4.
4, right? Does that make sense?
If it's a triangle, then you're going to times by each other and divide by 2.
Okay.
For the area.
What you're going to get
of it.
is you're going to get like mixed things too occasionally. And we are getting to the end of class here. Let's do one more of these here. Does anybody have this next one? You have it again?
So, for doing a graphic function, that's -1.
Okay, so that's a y-intercept of -1, right? So which way is it going?
It's going up to the right. So you positive.
Looks like it kind of got off the chart here, didn't it? A little bit.
And then the range is 1.4, so when you take the area of the triangle, it's going to be 3 times 4 divided by 2.
3, actually, it can be 3 times 3, right?
3 times. Oh, because it's 1 on 4.
So that's going to be what?
9 divided by
9 halves. Okay. And then what happens is we get into the other ones, that get the complexity raises a little bit on some of these. What we're going to do tomorrow is, and this is the one like the one Hannah worked out on the problem. Was it 2 or 3? 3, right? And so this is like the one on problem 3. So we get a negative sign. So what we're going to do is kind of pick up on this tomorrow, and then we're going to be also, I'm going to show you how to do these on a calculator tomorrow too. So just sort of get familiar with that. So bring your calculators or borrow a calculator. We'll have those available.
Do you have a Sharpie?
I may have a Sharpie. I have to go look for one.